Bom dia. Thanks, everybody. My name is Marco Noli. I'm the product manager for Viewpax, and I'm presenting today the future of radiology informatics as we see using artificial intelligence. This presentation was created, as you see here, the name Neville Skudovic is a Viewpax product lead. Neville wasn't able to join us due to the unfortunate events in the Middle East, being based in Israel, but he wants to convey that we surely have more opportunities in the next future to actually connect with the super dynamic radiology community in Latin America. So here let me present you what we prepared for you today. A little bit of a disclaimer, what we're gonna present in the next half hour is capabilities that are innovations, okay? So not necessarily scheduled for a specific, let's say, official release, but things that are currently worked on in research and development. So we're showing that to you as a kind of a preview of our innovation, of our direction moving forward, and we'll also move this show of some of these capabilities in the next RSNA, and also start implementing some first of kind at selected customer side over next year. Another disclaimer I want to say to convey that it emphasizes the importance of AI. So AI, from several perspectives, we don't at all see AI in replacing the radiologist work, but we see the AI complementing actually the radiologist's work, and of course we see the radiologist as validating and confirming what AI can provide as indication through the workflow. So a little bit of background. I think these concepts have been already exposed to you in the previous presentation this morning. So what is the background where we're playing as radiology informatics, and how can actually AI help us? So the background is, as we said many times, is increasing shortage of healthcare providers, including radiologists, together with a constant increase on the number and the amount of data to be managed by radiologists when reviewing images. So the big question in this context is how can a radiology department keep quality in the outcomes while facing this shortage of radiologists, as well as increased amount of data to be dealt with. So this is where we see technology being helpful in day-to-day activities. And we have let's say diagnostic radiology is a significant area for adoption of AI. In which context? We see clinical algorithms able to increase accuracy and the quality of outcomes while potentially reducing misdiagnosis, as well as large language models as ChatGPT, where algorithms can promote and actually enhance the radiology diagnosis by reducing errors and streamlining the workflows. So many companies have entered this artificial intelligence domain very similarly to what happened, let's say, in the 90s with the PACS business. So we see some focus areas where we are focusing as radiology informatics that are valuable for diagnostic radiology. So the area where we want to improve, let's say, efficiencies is quality, productivity, and communication. In the context of quality, AI can improve accuracy and efficiency by assisting and analyzing the vast amount of data that a radiology department has to confront every day. AI can also improve accuracy and reduce potential human errors by helping detecting abnormalities or patterns that the radiologist might miss accidentally. In the area of productivity, AI can actually leverage the ability to automate certain tasks that are, let's say, quite repetitive, although we know that each and every patient has specificities that need to be, of course, addressed. AI can actually automate certain repetitive tasks to help freeing time for the radiologist to actually focus on the patient and focus on the most complex cases. Actually, in the end, technology can perform faster than human eye, so we can leverage that capability of technology to speed up diagnosis especially when emergency situations require a very rapid reaction and assessment. In the area of communication, we see AI as capable of provide assistance for radiologists, potentially kind of saving the needs to provide answers for certain, let's say, normal studies. It can be fast-forwarded by AI and can be validated by radiologists. And this is especially valuable in areas where remote consultation is required, because areas that are with limited access to specialized radiologists. Ultimately, the outcome of the radiology, let's say, workflow is providing patients with a report. And AI can also help patients comprehend better medical reports, let's say, helping them to understand. And we saw before, right, in the Future Health Index, the importance for patients to be aware, to be involved in comprehend the radiology reports, and this will provide ultimately better healthcare. So this is also an area where AI can help us. A little bit outside of the radiology workflow, but still very important for providing as a radiology informatics vendor the best service to our customer. AI can also help assist us to expedite assessing of defects and expedite resolution of issues that are, sometimes encountered when working in such environments. Now we saw some examples, or like we just mentioned, great examples of valuable usage of AI. But before we go more in depth of such examples, I want to kind of step back a little bit and let's look at the patient journey in a radiology department. So all these steps that are shown here are, let's say, kind of well-known phases of a patient journey in a radiology department. So for each phase actually correspond a specific area in the radiologist's workflow. Now, from order creation to order scheduling, to patient preparation, examination, and report distribution, the radiologists come into play in different areas. And let's see how can, in the radiologist workflow, AI help to improve and streamline certain capabilities. So let's start with the first phase, okay, when the patient is admitted. The first phase where radiology is normally involved with is scheduling and registration. Now, scheduling is a phase where optimizing actually the agenda, the calendar of radiology department, we all know it's kind of a very tough and complex area. And we see the potential of AI here to actually analyze the data and improve certain functionalities. Now, to start with the optimization of modalities usage, we all know that this is actually an important point. And optimizing modalities usage requires analyzing a vast amount of data, like looking at the patient information, like the age, the kind of exams, the patient category, by AI can help automate this analysis and predict what's the best modalities used to actually optimize the scheduling of the department. AI, looking at such data, can also help reducing no-shows. No-shows is actually one of the biggest issues because it's a waste of resources for the radiology department. So looking at the information of the patient, his age, likelihood of not showing for a certain patient condition, the AI can help kind of potentially overbooking certain slots so that that modality can be best used and the resources available in the department can be best used for the purpose. So resource workload balance is also another area of very important potential for AI. Looking at what is the schedule of the department, especially in the case of multi-facilities, looking at where the exams are scheduled, how many people I have available for those days, the AI can help assigning the right people to the right shifts to actually have a better resource management and including load balancing and efficiency of the usage of the modality and ultimately reducing wasting times. So these are areas that traditionally are on the RIS, let's say, platform, as well as the protocoling and justification. Protocoling and justification is also typically a very time-consuming task for radiology department, especially for the radiologists. Why? Because in terms of validating a certain protocol or creating a certain protocol and checking the justification of that exams required for the radiologist to actually go through a certain number of checks, like confirming that the clinical need is appropriate, validate the anatomy and the laterality of the exam being requested, assess the priority, check the patient history to see if that is actually the right exam to be performed with that timing, check contrast indication, validating the protocol and potential contraindication for the medical condition. These are whole steps that are inherently done by the radiologist today when actually choosing the right protocol and justifying the examination. So all of these tasks can potentially be empowered by AI and automated so that the radiologist can actually already have a pre-assessment done by AI and streamline the workflow and actually have appropriateness validated without delaying the performance of the examination. Now, going back to our radiologist workflow, we move after the scheduling and the registration, the patient arrives and the image is performed, to the actual phase of the study acquisition and ingestion impacts. So at this point, the images are created, and the AI can actually help with a number of different algorithms. And the approach, as Philips, is to actually host multiple AI application into a single platform or as a single integration point with the PACS. Ultimately, the PACS is actually the workspace where the radiologist needs to work. So we want to make sure that the single integration point is provided with a comprehensive AI marketplace that includes AI algorithm from different vendors with a consistency and standardization of the data. Just to mention, we are also working at integrating with other AI marketplace solution that we have in the region, such as Carpal AI or Incepto, to achieve the same kind of results and make sure that the standardization to eventually streamline the AI results consumption impacts is done. Another area is of AI coming into play is actually, as mentioned before by Madhuri, is actually triage. So AI can actually assist in early detection of critical findings. So when a study is ingested in PACS, certain AI algorithms can intercept the critical findings at the moment that the images are stored in the PACS, even before the radiologists come and start reading the examination. And we can use this information in the PACS worklist to actually prioritize these exams and make sure that the radiologists will start looking at them with high priority. So the workflow is such that actually the patient comes into the radiology department for the examination. The images are analyzed by AI algorithms. The results of the AI algorithms are sent to the PACS, and this can be used for prioritization in the worklist and ultimately triaging. Eventually, when the radiologist will pick the images for start dictating or reviewing, the results will be presented in a consistent way in the viewer. When it comes to using the AI for data that are ingested into PACS, another very interesting area of work that we are investing on is data normalization. Data normalization refers to the process of standardizing data in a way that can be used consistently and across multiple applications and multiple usage in the system. The first use case is actually the display protocol, hanging protocols. I'm pretty sure that many of you are facing challenging with actually having the best usage of hanging protocols, especially over time. Why? Because the challenges that we have today, and this is across, I think, all PACS vendors, is the variability in DICOM tags, meaning that the DICOM tags can vary even within the same modality between procedures sometimes. And of course, there is no standardization of such DICOM tags across different vendors in the industry. Tag selection, because to actually select the right protocol and select the right images on the screen, we actually look at certain tags, and selecting the right tags is a big challenge because it can actually affect the performance of such display protocols. Ultimately, interoperability. We want to make sure that such hanging protocols can also be used across the board, across different systems, and across multiple devices, as I said before. So this is where AI can actually come to play and provide a solution in this perspective. So the concept that we are working on is to use AI to not just, let's say, look at single tags, but look at the group of tags in order to create standardized tags. Like here, we have an example of a standardized body part tag that is created by AI, looking at the number of data in the system. So such standard DICOM tags can actually be used to improve the consistency of the data and the consistency of the behavior of the hanging protocols, first of all, over time and across the board with different vendors. Display protocol is just one, or hanging protocols, if you will, is just one area of potential application of AI. Once standardization is actually achieved in a reliable way, we can expand this model to other use cases. Think about DICOM routing. We can use standard DICOM tags to actually route the DICOM data to a specific destination, such as an AI manager or advanced visualization platform. Okay, so we can automate and be consistent in the flow and the automation of the data. Workflow orchestration, of course, if we have standard data and standardized DICOM data, we can actually have better behavior of prioritization of exams and better work list management. Being sure that we build the exams and procedures rightly, right? Looking at the data, we can actually ask AI, or AI can help us, making sure that the billing is done properly when the data are stored in the system. When it comes to reporting, the template selection is also a very important point. Template selection, very similarly to hanging protocol, rely heavily on the consistency of the DICOM data. So once the DICOM data can be standardized, then the behavior of the selection of the right template when reporting can benefit from it as well. As well as mentioning a few other cases like research capabilities. So for research, we want to make sure that we archive or we organize exam in a certain way and potentially in an automated way. So standardization of data normalization can help us classifying studies, tagging the studies in a meaningful way for research purpose. As last but not least, also prior selection for follow-up cases. So this is also, again, back in the area of hanging protocols. So we see how many applications of data normalization we can explore, and this is something we started working on. And we actually just started with the hanging protocols, and we really plan to move forward in that direction. So this is about study acquisition and ingestion impacts. The next step is actually the viewing, reading, and reporting of the case of the study. In this area, we have several areas of focus from our research and development. First of all, we have been working at improving our organic clinical algorithms using machine learning potentialities. So we started with mammography, where we have a number of algorithms that are used today for the best display of the images on the screen. And we rewrote these algorithms based on machine learning to actually have the best performance of tissue detection and the usage of the tools that are normally needed for the mammography workflow. And all these tools work behind the scenes to provide users with the best experience when reading mammography study. Another area of organic algorithms improvements using AI is spine labeling. Spine labeling is something that I think everyone is doing since many years. No, in the majority of the cases, spine labeling is still done manually. So we worked at creating automation algorithm based on AI to create automatic spine labeling for CT and MR studies. So this will allow to actually label automatically the vertebrae, also taking into account some exceptions, like, or let's say, pathology specificities, like scoliosis and fractures, and allow the follow-up over time, and also enable correction tool when it comes to editing certain data that AI provides. Now, these examples that I mentioned here are organic algorithms. Like when I say organic, I mean embedded in the PACS viewer. AI also helps with the advanced visualization that actually can also be expanded out of the PACS viewer to use advanced visualization workspace. And that's something we'll have a dedicated presentation on that tomorrow. So we'll expand into this topic further tomorrow on this. So talking about, again, the visualization part, another area where we are working on is the organ detection, automatic organ detection. Now, when we say organ detection, we mean the ability to segment and define the contour of certain organs and certain area, of course, and certain tissues, sorry, in the exam, so in certain kind of images, such as X-ray, CT, MR, and ultrasound. Organ segmentation has a great potential of benefits. So first of all, we can improve workflow efficiency. In which way? When the organ segmentation is done in the system, we can actually enable some organ-specific tools just based on the position of the cursor. So when I place myself on a certain area of the body, the system knows which area I'm working on, and those tools can be automatically activated without the need for me as a radiologist to manually search for the functionality I'm looking for. And this is a very interesting area, and I have some more slides on that later. Education, training, and research. Automatic segmentation of organs can actually help understanding the anatomy of the patient, and of course, the AI here can help analyzing large data sets. Okay? So having a huge amount of data sets where the organ segmentation is performed can be used for teaching, especially in education hospitals. Treatment planning, okay? Having the precise location of the tumor size or the damaged tissue for radiation therapy and surgery is very important. And having such information available automatically when the radiologist is reviewing the images is very important and can be, of course, benefited to avoid during the therapy to actually touch healthy tissue in the patient. And ultimately also quantitative analysis. Having automatic segmentation can provide, without any further human intervention, automatic calculation of the volumes, for instance, or definition of the volume of the organ shape and characterizations. So all of this information requires either using a specific application or doing a lot of manual work. And that's where AI can actually automate certain capabilities. So here is an example that I already kind of anticipated before of AI organ detection being helpful in the reading flow of the radiologist. So in this case, we have AI detecting the organ of the liver. So when as a radiologist, I actually place myself in the region of the liver, certain tools are automatically enabled so that I can go straight to the tools that are useful for me. And I can actually perform measurement or just get measurement automatically, as I said before, by the organ segmentation tool. Last but not least, and actually most importantly, if you will, is that the fact that we have organ segmentation allows us to characterize, in a way, the measurement or the lesion that I am working on. So the characterization of the measurement allows to populate automatically the report. And in this case, we have an example of the PACS reporting with the right information in the relevant section. And this is a very important point because it helps streamline the reading flow and populating the report where it's relevant for the radiologist. Okay? And the characterization of the lesion is a very important aspect, and we'll talk a little bit about that also later. Now, we have discussed about the image visualization capabilities that AI can support us with. Now we'll move a little bit into the reporting area, okay? The last but not least step of the radiologist workflow. In the previous presentation, I think Madhuri already presented some of the enhancements of potential area of improvement when talking about AI in reporting. And this is actually a kind of a summary of the messages previously discussed, which some of the challenges that we observe in the day-to-day reading and reporting activity is actually the fact that, first of all, the first step when we start reporting cases that have history, reviewing the patient history is a time-consuming task, as well as creating the impression is sometimes time-consuming, as well as prone to potential kind of either missing incidental or key findings, as well as giving the radiologist the burden, in a way, to actually be clear and descriptive enough in the impression, which is normally the most important part of the report. So that's where we see AI start being helpful in the radiologist's workflow. So we see the AI assistance in these phases of the reporting workflow. So the generation of AI, of a summary for the patient history can help the radiologist to better understand the patient condition and the patient situation without having to go through all the prior reports of the patient. Generating the impression automatically can help support the radiologist, speeding up the workflow. And this impression, of course, can be just reviewed and validated and edited, right? But maybe in many cases, this can already be good enough to go on and speed up the reporting workflow. Last but not least, AI can help with the quality checks. So check the final report before being signed, look for incidental or key findings, as well as suggest on the clarity of certain areas of the report, such as the impression. So just to show you that well, this concept actually is something that we have already started working on. Here we have the PACS reporting, and as a radiologist, I'm starting reporting, so I can have a button to actually generate a summary of the prior that I can review without going through all the priors, right? Another area is, as I mentioned before, is generating a draft impression. So click, with a single click, generate a draft impression that can be included in the report, as well as, using this capability, perform a quality check of the report. So before the report is signed, AI can assist in perform the quality check and potentially indicate an area of improvements in the report. And all of these things now, of course, this is work in progress, but we can automate these processes using like voice commands or automated capabilities, right? So that we don't have to go there and click every time. But I just want to show that this is something that can be visually very significant, impactful on the radiologist workflow. So this is about the creation of the report, okay? But we can also look into to a broader picture of how can we, or how should we use and consume AI findings that are collected from different algorithms, and as we said before. So we talked already about the fact that we can have early detection of critical findings to triage and prioritize the work list. But eventually, we never went to the image management part and see how these results are consuming. So now we see in this summary view that once the AI findings are detected and stored in the PACS and available in the PACS, the AI results can be consumed and viewed over the images and potentially converted into bookmarks so that they can be easily accessible, as well as using such results to populate the report in a meaningful way. So let me just walk you through a little bit of a few steps of this workflow so that you can have a little bit of a visual picture of such concepts. So now let's imagine that the patient has arrived for a procedure and the AI algorithm, whatever AI algorithm we're talking about, has been executed and the results have been sent on the PACS, and we have a finding. Okay, we have a finding for such study. So now as we said before, the work list can be updated in real time, and first of all, we can display this in the PACS work list with an indication that we have AI findings, and hovering with the mouse over the AI findings can actually show what the AI findings is about, which AI algorithm have been used, and what is the finding specific for this patient. Now, we didn't say that because here for this example is not so relevant, but of course this can be used for prioritize and triaging the case in the work list. When the radiologist actually open the images, such AI findings are converted into visible bookmarks and displayed over the images. We can have an indication with the color that clearly suggests that that is a suggested finding coming from AI. And we can, of course, review such finding as we did before from the work list. And at this stage, this is a very important concept that we are working on, is the value of the radiologist in actually validating and accepting such finding, okay? So we're not using the AI as is, but we're using AI to support radiologists in having a finding that eventually the radiologist will have to check, confirm, and validate. But that will be a very simple, as simple as clicking on an accept bookmark, like in this example. So the suggested AI finding can be either accepted or rejected. When it's accepted, can be displayed on the images then for consistency over time. But most importantly, what we're showing on the left side of the screen here is the report. So this accept bookmark task can be used to automatically populate, and let me show you here, the report with the finding. Now this links to what I showed you before, the contextualization of the finding. AI can provide us all the information for this finding, for this bookmark, to be placed the information in the right section of the report. And this is very important because it saves the time, of course, copy-pasting or redictating certain feature of the study, as well as, of course, streamlining the radiologist workflow. Once the data are automatically inserted, then the radiologists always have the capability to edit, adjust the report, and then you ultimately validate. Now, something that is behind the scenes here is the fact that the AI finding that has been accepted or rejected by the radiologist, we can use this information to actually feedback the AI engine to improve the performance over time. So this is actually the machine learning concept that is laying behind. And we can do this without really disrupting the radiologist workflow. And this is something that we are keeping very much focused as a point in building this solution. We want to make sure that there is no extra work for the radiologist when using these AI functionalities, but at the same time making sure that the data that the radiologists provide to the system are used to improve the performance of the AI algorithm. And this is about the AI results ingestion. So this kind of a little bit conclude the radiologist part in actually reviewing the images, creating the schedule we said before, ingesting the images and creating the report. Ultimately, we have report distribution, okay, which is normally done quite automatically, we can say, nowadays. A report distribution is actually consumed by patients. Okay, so this is still an important step and is an area where we see the AI also coming into play. So when we actually talk about report distribution and report consumption, let's think about how many times we have examples in, as clinical professionals, but also as part of our families, of findings in the report that are not understood by average patient. Okay? It is very common, and I've been exposed to that myself many times. And how good would be for AI to provide a solution that provides clarity to the patient. So where a specific sentence is in the report, then it's translated into something that can be clearly understood by everybody. And this comes into the concept that we said before about the importance of having the patient's understanding and being engaged in the process of care. So as patients have greater access to the medical data and medical reports, they don't often understand the full meaning of reports. Okay, and this is unfortunately the case in many times. So there have been suggestions about ideas of creating side sections in the report or parallel reports that can be understood by the users. But all of these ideas that are kind of manual and disrupting the radiologist workflow. So the intent here is to have this automated so that we can have that done automatically without even the radiologist caring about it. And ultimately, of course, we want to improve the patient understanding of the report. So a large language model has the potential to simplify the imaging reports in a seamless way for the radiology department, for the creator of the report, and ultimately for the patient. Our plan is to enhance our patient portal, which is the solution that we have in radiology informatics to distribute the report to the patient, to include such, we call it lay reports capability through the usage of large language model technology. So how we can do that, basically, as a first kind of a visual walkthrough, when the report is displayed to the patient in the patient portal, and a certain area of the report is not clear to the patient can trigger a specific kind of explain feature as part of the report. And this will use huge large language models to actually explain to the patient what that specific section of the report means, and together with the source of those data. Our plan is to actually leverage databases that are reliable and are recognized by the clinical community, okay, and not just general large language models interpretations. So this is a use case that we're working on as part of our patient portal solution. And this case is actually selecting a specific part of the report. And of course, this can be expanded to generate a comprehensive report summary that the patient can read and that translate the meaning of the radiology report created by the radiologist to a more comprehensible report delivered to the patient. Okay, so these are the areas of improvement that we are working on and actively working on in our research and development department. And not just in the product itself, but also in the way we can service you as customers. We want to also leverage AI capabilities. So as I said before, we don't want to limit that to the product, but also to the way we serve you and we serve the product. So in the service and support area, you can imagine, because we have, it's kind of a parallel to other kind of ticket and support opening. We have several steps of analyzing the data to get to your resolution. Okay, a case is opened normally by you and your teams in the system, or actually a call is done to our support team, and then our support teams are analyzing the data that are not always consistent and not always like straightforward to understand the urgency of the case and progressing the case along the investigation process to get you to a resolution. So all of these steps traditionally are done mostly manually. Okay, of course we have information system to store those information, to those data, but the people behind are actually doing several steps manually. So that's where we see AI coming into play and help us streamlining and enhancing the quality of support, is the categorization of data. So categorizing an incident ticket is very important because it helps giving the right priority and making sure that that ticket is being taken by the right person and treated in the right, with the right urgency. So categorization is a task that if performed manually can take very long. And we have examples. We measured at categorizing manually a number like 100 tickets can take us like up to 4 or 5 hours, while AI can help us doing this in a matter of 30, 40 seconds. So this is very important to help getting fast categorization of the tickets and ultimately providing with faster care and faster support. And ultimately, have better satisfaction for you in your day-to-day activities. So we saw a number of applications of AI that we are working on and that are, let's say, comprehended in the area of what we call AI for radiology assistance. I hope this gave you a good overview of what we're working on, and this direction resonates with you. We're really looking forward to actually implement such solutions at your hospitals. Just to conclude and summarize this presentation, with AI we help healthcare providers and patients to make sense of the medical data explosion. As we said before, medical data explosion is one of the biggest things in the industry. And our goal is to combine the power of AI with deep clinical knowledge that we have as a healthcare provider to create integrated workflow solution in the cycle of care. And our approach, as I said before, is not to replace the radiologist with AI, but indeed to help radiologists increase the quality of what they do every day, saving time and reducing the cognitive load. And that concludes my overview, and thanks a lot for your time.